Top Secret Psi Operative Training Mission. Introduction to Waves. Mission: understand waves, what causes them, and how they transport energy. Use the help of the PsyOps team to understand the concepts and prepare for your missions. Tips: remember to beam as you read through the passage below.
To defeat the hive, I've created a laser that converts electrical energy into electromagnetic waves that melt the shield and the armor of our enemies. Engineers must understand all the properties of waves and how waves differ from one another in order to design safe and effective technology. As a future member of the PsyOps team, you also need to understand waves and how their properties can aid us in our mission. Waves are everywhere. In fact, you encounter waves on a daily basis. A wave is a disturbance transporting energy from one location to another. Waves are created when a force, a push or pull, creates a vibration. These vibrations are wave-like disturbances that move through a medium and spread away from the point of origin.
Interesting, Nicole. But what do you mean by medium?
A medium is a substance or material that carries the wave. For example, a gas, liquid, or solid substance. Some waves can travel through a vacuum, which is an area that has very few or no particles. When a wave travels through a medium, it causes particles in that substance to oscillate. Oscillate just means that the particles are moving back and forth in a regular repeating way. After a wave passes through the medium, particles return to equilibrium. Equilibrium is the original resting position of the particle.
But what does that mean? How do particles rest?
When we say a particle's resting position, this just means the position the particles were in before they started to move to make a wave. You can think about it like this. If you pass a ball back and forth between your hands, the hand it was in to start with is like the resting position or equilibrium. When you pass it back and forth, it keeps passing back to the original position, your hand, on its way to moving again. In a wave, the equilibrium position is usually just in the middle of the wave since the particle moves back and forth compared to where it started. In the returning to equilibrium diagram, we can see the process I described. The particle starts out at the equilibrium position and then oscillates to the left. As it moves to the right, it returns to its original equilibrium location. As it continues moving, it oscillates to the right and returns back to the original equilibrium position as it oscillates back to the left.
That makes sense. But how are these moving particles creating a wave?
The wave forms as the energy keeps moving from one place to another as the particles oscillate and collide. When you see a wave move through a substance, you are observing the movement of energy through the medium. A wave does not transfer matter, and it isn't just one particle moving. It causes particles in matter to move up and down, or left and right, but the particles always return to equilibrium.
Are there different types of waves?
Yes, there are two main categories of waves: mechanical waves and electromagnetic waves. Let's take a look.
Mechanical waves. Mechanical waves, such as sound waves, are produced by a mechanical movement or vibrating object. Mechanical waves can travel through a solid, liquid, or gas, but not a vacuum. These waves transfer energy through a series of collisions. An initial particle is disturbed, then collides into other particles, which then continue to collide with other particles to transfer energy through the medium. This is why mechanical waves require a medium to travel through. There are two main types of mechanical waves: transverse waves and longitudinal waves. With transverse waves, particles of the medium move perpendicular to the direction of the movement of the wave. In other words, particles move up and down when the wave moves left or right. We can see this in the example transverse wave, where the particles are oscillating up and down as the wave energy moves to the right. This pattern of movement stays constant throughout the medium, leading to a regular wave pattern. With longitudinal waves, particles of the medium move in the same direction as the movement of the wave. In other words, particles oscillate parallel to the direction of the wave. In the longitudinal wave on the right, the particles are oscillating left and right as the wave moves to the right. This is what is meant by parallel motion. Electromagnetic waves. To understand the other main type of waves, electromagnetic waves, you need to first know a little bit about electric fields. Electric fields are created around charged particles. When these charged particles interact with magnetic fields around planets or everyday objects containing metal, this can cause the charged particles to oscillate. As the particles oscillate, it creates the electromagnetic wave. Like some mechanical waves, electromagnetic waves are transverse waves. Unlike all mechanical waves, they can travel through a vacuum and don't need a medium. The light we see, the energy that cooks food in your microwave, and even the X-rays you get at the dentist are all electromagnetic waves. These types of waves are also what we will use in our laser to melt the hive's armor and save the captured scientist. Everyday items that emit electromagnetic waves: mobile phone, radio, lighting, microwave, television, Wi-Fi, electrical wiring, remote, and computer. Thanks, Nicole. This information will be helpful for our PSYOPs team in the field. Make connections. In each box below, write a connection between the text you just read and either your prior knowledge or something in your life. Reading comprehension questions. Introduction to waves. Number 1. What does a wave transfer as it moves? Circle 1. Energy or matter. Number 2. What are the two main types of waves? Blank and blank. Number 3. Which type of wave requires a medium to travel through? Number 4. Explain how a wave moves using the terms medium, oscillate, and equilibrium. Number 5. Compare and contrast transverse and longitudinal waves. Number 6. True or false? In order for Akai to hear Nicole's commands during a mission, air molecules must move from the lips of Nicole to the ears of Akai. Explain. Number 7. As the hive travels to our planet through outer space, would they be able to A. Hear the sound of a nearby spaceship as it zooms past at high speeds? Explain. B. See the lights of the nearby spaceship? Explain.